In Lesson 72, we'll be learning about factoring trinomials where we have sums as factors. We have to factor those out first, and then we'll learn about some volume and surface area formulas for pyramids and cones. To understand factors that are sums, let's go ahead and do some practice problems and look at practice problem A. Now, we've learned how to factor trinomials. We've learned how to factor greatest common factors out of trinomials. Now we're going to look at sums and find sums to factor out of trinomials, and then we factor the trinomial and factor it into two binomials. Now these problems, those are contrived problems just like the ones in Lesson 71. After we're done with our factoring of the greatest common factor, then that trinomial that's left, it'll have an x squared, an x, and a constant term, and we will be able to factor it into two binomials with whole number coefficients in them. That's how the problems are designed. So if you don't get it factored into two whole number binomials, then you did something wrong. So look at this problem here, and let's just look at it and see if there's a factor we can factor out that is common to all the terms. And there is an a plus b. And we think of that a plus b, anytime we have something in parentheses, we just think of that all as one factor. So just think of the a plus b as one factor. And then here's another a plus b, and here's another a plus b. And you might want to do this just like I have and underline those sums, and that helps you get organized and helps you recognize right away that there are common factors in each of those three terms. So let's factor that out. A plus b, leave it in parentheses, and then we'll be left with x squared minus 8x minus 20. Okay, now let's factor that trinomial into two binomials, and we'll have a plus b, and then make two pairs of parentheses, x and x, and we need to think of what two factors of negative 20, if we added those together, would give us a negative 8, and that would be a negative 10 and a positive 2. So we'll say plus 2 minus 10. And so there we've got it, our factored form of that expression. Let's do one more of these. Look at these three terms, and first let's see if we can find a common factor to all of them. Well, we can see that c plus d in there, and that's in all of them. That's a factor. Always think about whatever's inside the parentheses as one individual factor. So they all have that, so we know that's a common factor. And then we also notice there's a minus sign out front of the first term, the highest degreed term, so we want to get rid of that minus sign too. We want to factor it out, in other words. And so we'll say minus, and then there's also an x. Everything has an x in common, right? So let's factor an x out, parentheses c plus d. And then we'll set up our parentheses for the trinomial, and we'll have an x squared. Then we would need to make this a minus 3x, because minus 3x times the negative on the outside would give us a positive 3x squared times c plus d. And then the last one will be a positive 2. So there's our trinomial, and we have everything else factored out. So we'll have minus x times c plus d, and then make two binomials. Put x's at the beginning of each, and let's just think about our trinomial. What factors of 2 could we add together to get a negative 3? Well, we'd have to do a minus 2 times a minus 1, because minus 2 plus a minus 1 would give us minus 3. And so there's our factored expression there. A little long, a little complex, but if you just recognize that that c plus d is one individual factor and think about it that way, that helps you simplify how you solve the problem. Basically, it just simplifies it in your mind. Part B of this lesson is on cones and pyramids. Now, a pyramid, that's like a prism. We learned about prisms back in lesson 60. They have a polygon for a base. The other faces are triangles on a pyramid. Now a cone, it's like a cylinder, and it has a irregular, or not a irregular, but a curved surface for its base. Pyramids are like a prism. They have a polygon for a base. Cones are like a cylinder. They have a curved surface for a base. Now if you were to draw a line, we'll just put a dashed line to represent an imaginary line, from the top down to the very center of either one, that's considered the axis of that pyramid or cone. And if that axis intersects the base at a right angle, we call those right solids, or right pyramids, or right cones. So in those two examples there, I've tried to draw a right pyramid and a right cone. If that axis is tilted from 90 degrees either way, then you just call it a pyramid or just a cone. Then that distance from the base to the top, that's called the altitude. And I'll just say ALT for short on that. That's considered the altitude. If it's a right cone or a right pyramid, that's the same thing as its height. But the altitude is always the perpendicular distance from the base to the top of the cone or pyramid. So if it's just a pyramid that has an axis that's slanted either way, you still say the altitude is the perpendicular distance from the base to the top. If it's a right pyramid or a right cone, as these examples are, then it's the same thing as its height. Now there's a special formula for the volume of a cone or a pyramid, and it's just like a prism or a cylinder. It's the area of the base times its height perpendicular to the base. But then you take that amount and you multiply it by 1/3, and that's the volume for a cone or pyramid. Look at the example of the pyramid. If I pretended like I had a rectangular shape here, and I fit this pyramid inside that rectangular shape, we would see that basically it fits about 1/3 of that rectangular prism. So that's why the formula for a pyramid is 1/3 of that whole prism shape. If you had an entire rectangular prism, the pyramid that would fit in there that had the same height as that rectangular prism that I've drawn in red, its volume would be equal to 1/3 the area of that base times the height. Now if you wanted to figure out the surface area for a pyramid, all the faces are triangles except for the base, so you know how to figure out the area of a triangle, so that's really not very complicated. They'll always give you enough information to figure out the area of each triangular face. A cone, though, the lateral surface area, which is the area around the sides, that would be kind of difficult to calculate because it's a curved kind of surface. It's not like a triangle or anything. And what you do on that, there's a special formula, and we'll say LSA for lateral surface area, and then subscript cone. That's equal to pi times the radius of the base times the slant height of the cone. This is the slant height. Look over on the cone. I'm drawing it right now. It's the side, basically, from the bottom to the top, how long that slanted side is. So it's pi times the radius times that slant height L. That's how you figure out the lateral surface area for a cone. So if you want to know the total surface area for a cone, you would figure out the lateral surface area and add to that the area of the base. Let's go ahead and do some practice problems. For that pyramid that I have drawn there, I've redrawn one of the faces of it, one of the triangular faces, so that you can see what its dimensions are. And then I've shown you that the altitude is 10 meters. We already said it's a right pyramid, so that would be the same thing as its height. I want you to find the volume and the surface area for that pyramid. And so what we need to do is figure out the area of the base. And also we can assume it's a regular pyramid, so that means all of the sides are the same length. And so if we want to figure out the area of the base, that would just be 8 times 8. It's a square, basically. And so we'd say 64, and then times the height of 10. Now the volume is going to be 1/3 of that though, because it's a pyramid, not a prism. So we're going to do 1/3 of that value. And so we'll do 640 divided by 3. And that's about 213.3 repeating. So let's just round it to 2 decimal places. 214.33 cubic meters. Our units are meters there, and we're doing volume, so that would be the volume, 214.33 cubic meters. Now, just to make sure that you understand, volume is the area of the base times the height, and then times 1/3 of that. And the area of that base, it's a square basically because it's four-sided, and I said that it's a regular pyramid. That means all the sides are the same length. And so that triangle that I have drawn there next to practice problem A, the base is 8 meters on that, and so that's one of the sides of the four-sided base. Now to figure out the total surface area, we have 4 triangular faces there, and each one of those has a base of 8 and a height of 8. So to figure out the area of one of those triangles, that would be 8 times 8 over 2, because that's the area of a triangle, base times height, perpendicular to the base, divided by 2. There's 4 triangles altogether, so we multiply that amount by 4. Add to that the area of the base, which you already calculated is 64. Then we can simplify this, 4 over 2, that equals 2. And so we'll have 8 times 8 times 2, and that's just 128, plus that 64 would give us 192. Now this is surface area, so the meters, or the units are meters squared, because we just multiplied 2 lengths together to figure out area, right? So it's meters squared. Volume, we multiply 3 lengths together. That's why we get meters cubed. Let's do one more problem. I want you to find the volume and the surface area for that cone. And I've given you there in practice problem B the dimensions that you need to solve that. The radius is 4 inches for the base. The altitude is 8 inches. That's the red dashed line in there. The height perpendicular to the base. And then the slant height, L, is 10 inches. Let's figure out the volume first. That's the area of the base times its height, or in this case, that's the same thing as altitude, since it's a right cone. So the area of the base, that would be pi times 4 squared times its height of 8 inches. And then all of that times 1/3, or we could just say divided by 3 as well. So you can just go ahead and do that on your calculator. 3.14 times 16 times 8, and then divide that by 3. And you get 133.97. We can just round it to 2 decimal places. 133.97 inches cubed. So if we didn't divide by 3, we'd be figuring out the volume for a cylinder with those dimensions of height and radius. Now just be wary on problems like these. The answer in the solutions manual, or the answer key, may be a little bit different than yours. It just depends on how they rounded the answer. But as long as you're real close, then don't worry about being off by a couple of decimal points. And so that's the volume for that cone. 1/3 the area of the base times its height. Now let's go ahead and figure out the surface area. The base, that would just be pi times 4 squared, or 16 pi. And then the lateral surface area for the cone, we use that formula, pi times the radius times the slant height. So we say plus pi times 4 times the slant height of 10. And so we end up with 16 pi plus 40 pi. That's equal to 56 times pi. And so you can just do that on your calculator, 56 times 3.14. and that equals 175.84. Remember, we're doing area here, so the units are inches squared. Units are just as important as the answer. So it'd be a good idea to memorize that formula for lateral surface area of a cone. Pi times the radius times the slant height, L. That's not L for length, it's the slant height of the side there. Volume of a pyramid or a cone, that's equal to 1/3 the area of its base times its height. Okay, well that's all for lesson 72.